While everyone's obsessing over AI, there's a transformation reshaping your network infrastructure, a change that could cut your costs in half. You see, for decades, we've kept optical transport, layer 1, and routing, layer 3, in separate worlds. But now that's all changing. The convergence of these technologies isn't an emerging trend, it's a necessity. You see, the old ways of managing network growth can't match today's demands. And that's why in WWT's latest research paper on networking priorities for 2025, converged network architecture ranks as priority 3. So what does that mean for you? Lower costs? Faster deployment? How about a network with fewer moving parts, which equals, well, less complexity? And joining me today are two experts from Worldwide Technology. Tyler Tappy specializes in optical transport, and he's going to show us how new pluggable technology is eliminating entire systems of hardware and slashing power bills in the process. And Josh Hogan, well, he focuses on core routing, and he's going to explain why this technology is now ready for prime time, whether you're running a service provider network, enterprise campus, hospital system, maybe a university infrastructure. Bottom line, wherever you've got your own fiber. You see, for years, optical and routing teams have worked in separate silos, but now these walls are coming down. They're offering greater efficiency, cost savings, and unprecedented agility in how networks are built. So if you're in charge of scaling your network for the future, this conversation isn't just helpful, it's critical. My name is Rob Boyd. Welcome to WWT Presents Research.
WWT Presents Research.
Josh, tell me what you do for Worldwide Technology. I know we've done this before, but I want to make sure that the audience understands the distinction between you and Tyler, because I think it's important and incredibly valuable for today's discussion. But welcome, Josh.
Sure. So like Tyler, I'm a technical solutions architect here at Worldwide. I am on our core networking team, which Tyler and I are both a part of, and we represent two sides of this team. So our team, core networking, is broken down into an optical transport side, which Tyler is an expert in, focuses on DWDM type of technologies and long-haul transport. I'm on the what we call core routing side, which is the things like MPLS and BGP you typically think of as like carrier grade routing. Been with Worldwide now for, my goodness, I'm at like 7 years now. I am a triple CCIE with Cisco, including service provider and security.
So SP, security, and routing.
Exactly, yeah.
Okay, so all the easy ones.
Enterprise infrastructure, I guess now, but back in the day, I was routing and switching.
Yeah, half the exam is just keeping up with the name changes.
Exactly.
Yeah, I'm just kidding. I as one who's not taken the exam, but I love just throwing in commentary. No, that's cool because I think also you started mentioning what Tyler does. So, well, let me put it in your words. Let you put it in your words. Tyler, what do you do for Worldwide Technology, especially as it relates to what Josh does?
Right. So I am more on the optical transport side. So from that perspective, there's a lot of optical transport out there in the world. It's connecting anywhere from small cities to across the world. So that's everything that's light-based, essentially, and there's a lot of transport systems. I've been with WWT for 5 years now, just had my 5-year anniversary. And prior to that, I was with another systems integrator where we did very similar stuff. So I've been doing this for roughly 20 years. I've done everything from the integration, implementation, deployment, all that stuff, like boots on the ground kind of stuff, all the way to the stuff that I'm doing now, which is the design and architecture of these optical systems.
You know, in our warm-up, I should say, but our discovery call, when we were kind of catching up with each other, because we have recorded before, because this space continues to change in very valuable ways, and it's important to call this stuff out. And so it's in the priority report. I believe we're on priority 3 for networking. We've spoken before, but it's interesting how you guys continue to be under the same pressure I feel like customers are under in terms of how you even organize yourselves to help customers, because there is so much bleed over in your disciplines. And so we're going to get into some of that here, but let me go ahead and open that up and say, Josh, I wonder if you could set the stage for us in terms of what's important to understand in 2025 in this converged networking space.
Sure, yeah. So, and it's a great lead in, I appreciate it. To really frame it up as an update, because like you mentioned, we've done this before. We've been having this conversation now about converged optical routing or routed optical convergence, whatever you want to call it. We've been having this conversation for almost half a decade now. So it's getting pretty established. And I would say that's the first major thing. If I can make two main points, the first major one would be this is now very mature technology. So sitting in 2025, I would say the vast majority of core network designs probably need to include at least some consideration for convergence. The technologies and components which make it up, so the actual solutions that are being put into reality by the vendors, they're very stable now. This isn't, you're not at the bleeding edge of the curve if you're adopting this technology today. So the first thing is I think we've reached a good stable maturity in it. And it's now at the point where I think if you're not including this in your design considerations, you're probably starting to get left behind because some of the things that this technology can do are very cool. The second thing I would add is that we're at a point now, specifically in the last couple of years, where there has been a rapid acceleration of all of the functionalities that have been put into these pluggables, which we'll talk about a lot, these coherent pluggables that go in the router. Initially there was, I would say a couple years there in that like 21 to 22, maybe into 2023 timeframe, where we were really just talking about like 400 gigs ZR and ZR plus. It was in a QSFP DD form factor. So if you wanted to go converge, you really needed to like look at routers that had that form factor, which you probably didn't have already. So you were looking at buying routers. It was a very like singular focused discussion on getting in that direction with those ports and that specific technology. Well, now there's a lot of different ways to do it. 800 gig is out today, as well as we've actually backed into 100 gigs. So we can now do this on QSFP 28 ports, and all of the vendors right now in early 2025, they're kind of just now really starting to roll heavily with that, as well as a lot of optical functions that at first we weren't even considering doing with the pluggables. Now we can do. You can actually filter with pluggables. You can amplify with pluggables. A lot of these pluggables now are what's called bright. So they're actually outputting at a very high power output, which allows us to shoot further and do more with it. So just the design options and the types of things that we can do have really expanded dramatically, I'd say, over the last year or two. And those are my big two takeaways. This stuff is mature, and it's actually at an inflection point where now I think it's so stable that we're just starting to get a lot of different things that we can do. So it needs to be at the top of your design consideration list.
Well, and really what we're talking about when we talk stability is not just technical stability, but it means that everything from standards to vendor buy-in seems to be settling in, which has price considerations because of increased options and just the ability to kind of make decisions in this direction without fear that you're heading off in some type of a unique trail and blazing a path. You're not in this case. So we're talking about lighting up dark fiber for everything from, normally consider this be service provider technology, but this is really enterprise space, campus networks. I think you mentioned metropolitan area networks. There's many more of these things, I think, than I ever remember or even realized that we depend upon. But with all that terminology you're throwing out there, Tyler, I wonder, you did a really good explainer. I was impressed with. I wonder if you might walk us through these changes using your explainer, because I think that does a good job of laying a foundation of what's important to understand on the changes here.
Sure. Yeah. Thanks. Josh did a really good job explaining, what we have now, what we're looking towards incorporating in the future. But just to kind of backtrack a little bit and explain what is this converged thing that we're talking about. Not everybody calls it converged. That's one thing I just want to get straight out the gate. This is something that folks call Cora from Juniper. It can be called routed optical networking. There's a lot of different things it can be called. So with that, what exactly are we talking about? We're talking about taking a function that was traditionally in an optical transport world and putting it into a router. So specifically what you're looking at here, this is a Cisco optical transport system. This is the NCS2K. And within those chassis, you have a specific device. It's highlighted now. That's a muxponder. It can also be a transponder. But what this thing is capable of, it's capable of taking in multiple client connections at a gray light level, meaning it's not DWDM. So traditionally, these have taken in connections from routers, switches, servers, what have you, on a gray connection. After that, it adds in a DWDM wavelength. It also gives it some high performance optical stuff. So G.709, which gives us enhanced spec, coherent, just to name a few, plus a high output transport power. So it's taking in client connections and pumping it out a DWDM wavelength. What the industry's been able to do with this is take that and shrink it down to the size of a plug. So in the middle, we're looking at a QSFP-DD pluggable form factor interface. And in reality, what you're doing is taking that plug and putting it directly in the router. So you're consolidating that power, that cooling, all that space, and that traditional optical transport system. You're putting it into a pluggable optic. So this isn't the first iteration that the industry's really tried to do this. In the past, they've done this before. It was just very big, very bulky, and very expensive. So the really big change in what's really made Converged take off is the fact that they were able to make it small, they were able to make it cost effective, and they're able to make it easily adoptable through a common interface, something like QSFP-DD. And that's just the first iteration. Like Josh said, they backtracked. So they went 400 gig QSFP-DD, and then they backtracked to QSFP 2800 gig. Same functionality, same kind of stuff, but QSFP 28s were out there for a long time, but there was a major powering and cooling consideration that had to happen with those pluggable optics. But yeah, in a sense, that's what Converged is. It's taking something from an optical system and putting it into a router. And it goes beyond this too.
So we're getting rid of extra physical devices to do things, and those things, that's just problematic in and of itself, and this is the way technology sometimes goes, but they had to solve some power problems. And even today, I believe, there's some vendor differences in terms of how much power you put into it. But the main point I think you're trying to make, or that you are making, is that these fit into a form factor that you may already have existing gear, or you have the ability to purchase gear that is basically purchasing less gear to achieve more output and more capability with it. You had a second visual as well, I think, or a second walkthrough?
Yeah, I do. And it just kind of expounds upon what Josh was talking about earlier, and taking other functions and putting them into routers as well. We can take amplifiers or EDFAs and also put those into a router as well. So in any optical system, distance typically matters. And with distance, we have light loss. It's inherent of all optical light. Over space and distance, you're going to lose some of your intensity of that light. It happens regardless. In order to overcome that distance and that loss, we usually have amplifiers. Those amplify the light so you can reach longer distances, essentially. So what the industry's been able to do is take something like a pluggable QSFP-DD interface and put an amplifier, or in some cases we call them an EDFA, onto the system. You take that, it's another pluggable optic that sits in your system. And the really cool thing about the way this works is you can take those 400 gig pluggable DWDM interfaces, slap those alongside your EDFA or your amplifier, and then they have incorporated multiplexing DWDM filters. So you can take in multiple wavelengths into these things, and it's all done within the fiber itself. So it's just kind of a crude drawing of it, but there's an instance of a 400 gig going into a multiplex filter, and you can expand upon that. Yeah, I think right now there might be an 8-channel filter, but this is going to grow and this is going to get bigger as this technology keeps getting more widely adopted. And what you ultimately look at is, hey, I have 400 gigs going into a octopus cable fiber that's going out an amplifier down to the next site. This used to be in a big system taking up many rack spaces with a lot of cards across it, taking a lot of power. So that's kind of the other cool things. And now they're also talking about OTDR on a stick, optical time domain reflectometer. It's a testing device we use to tell us how long the fiber is, if there's a fiber break, how much loss there is, stuff like that. So they just keep incorporating more and more pluggable optics to do traditional optical transport functions.
OTDR, essentially, because that's a monitoring, that'd be a separate device, right? That would yet another thing that you need to understand that if there's breaks or weakness in the system somewhere that needs to be addressed.
Yeah, absolutely. Yeah, it's typically it can be a physical device that you plug in and you test with. In a lot of cases in the optical transport systems that we sell today, those are incorporated within the system. It's just another way to get all of the stuff that we're traditionally doing in these optical transport systems directly into the router.
Who is this really for in your estimation? Who should be paying attention?
Well, you made a good point of almost correcting me earlier in making sure to insert that This is really relevant to anybody who owns their own long haul fiber and really even, campus fiber strands. It's very interesting. This technology, it's not just on carrier grade equipment like what I work with every day. You think of like MPLS supportive equipment, things that'll do MPLS VPNs. They're also putting it very heavily into Nexus. So after all of the, let's use as an example Cisco's NCS or ASR product lines, their carrier grade routing product lines. Well, the next most popular product line for this technology is the data center stuff, the Nexus stuff. And the reason is you might have, interconnections where you want to beef up this bandwidth and utilize a lot of this 400 gig technology. So basically, I think it goes back to my original point about this is now becoming very mature and stable. The technology is dependable from an investment protection perspective. And it cannot be overstated how important it is that the QSFP-DD form factor always had reverse compatibility. So you can throw a QSFP28 optic in it and run 100 gigs. You could even downgrade it all the way down to 10 and 1 gigs on that one QSFP-DD port, which will run 400 gigs for you. I mentioned at the top that I'm a triple CCIE, and it's only really in the last few years as I've worked a lot of IPv6 projects that I've really developed an appreciation for how egregious it is that IPv6 didn't have any backwards compatibility. It's one of the huge sticking points. And I think we all knew back in like 2021 and 2022, you knew that QSFP-DD was going to be the way forward. The vendors were just really locking in on it. I feel like now from the 2025 perspective, you can look back and see very clearly it was that reverse compatibility that made it widely adoptable. Because one of the functions here that Tyler's talking about is using adjacent plugs, adjacent ports to do other things besides just lighting up the coherent link that we need to light up. You can do that because of QSFP-DD. One of the things that the vendors do is they'll have cards or slots that have, say, 5 different ports on them. This card will only be 400 gigs of throughput supported. One port for QSFP-DD if you want to run that, and then all, say 4 ports of QSFP28 at 100 gig. And the reason is to give you mix and match and options and let you do what you want. Well, now you can run your 400 gig using a coherent, but you still have that plug and its power capabilities to be able to insert any of this other optical equipment. So as all of this stuff has become really stable and really settled in very well, I feel like it's been a big hit. It's opened the door to much more than just, service providers or even organizations which just own their own long haul. If you need to interconnect, there's a lot of, I use the term campus, and campus is a little bit of a misnomer because really what you're talking about is metro applications, right? So things like hospital systems or university systems where you're traversing a fairly long enough distance that to get multiple 400 gig shots, coherent will be a really, really good way to do that. It doesn't necessarily need to be like you're jumping multiple hops to provide a very large regional, service provider type of footprint. So it's all over the place. I feel like it's relevant to anybody who, like you said before, really runs their own dark fiber. It's going to be something that they need to consider.
There is no standard-based design model for this. The one I was showing earlier with an EDFA in a router or an amplifier in a router, that's just one model. Josh and I work with plenty of customers where their requirements for their network aren't always the same. Lots of folks have optical transport systems, DWDM ROADM systems, and they need to keep those and maintain those for specific reasons. There's nothing saying that you can't take a wavelength on your network and put pluggable coherent optics in it and use it for something else. A good example of this is service providers. They have typically MPLS rings where they might carry their broadband internet on. So you're at your house, you get a 400 meg circuit, they'll carry that on a coherent routed optical network or a converged network. They might also lease circuits across their network where maybe another service provider needs path through their fiber footprint, or they need to get a bank directly to the internet. Those are written in a certain way where that needs to be a true layer 1 circuit, where you can't really do that on a converged network. And then a lot of our customers, even one that Josh and I are working on right now, some spans, they might have tons of fiber to work with and they don't really care. They don't need to multiplex it with the DWDM filter. So they'll just have a 400 gig pluggable connecting to a 400 gig pluggable over long haul dark fiber without anything else in between, just the pluggable optic, the pluggable optic reaching 80 kilometers, no problem. So it's all dependent on what your requirements are, but Josh nailed it when he said that really only the requirement that you have is that you maintain your own fiber network. And if you have fiber footprint, that's it.
Are you also saying that that this isn't a all or nothing type of next step, that you can ease into this based on your actual requirements and start taking advantage of maybe certain but not all aspects, and that's perfectly fine.
Oh, absolutely. Yeah. And that's Josh nailed it earlier too. When he mentioned it's backwards compatible now with QSFP 28. So QSFP 28 100 gig capable routers and switches, they can take in these optics now more elegantly than uplift a whole new chassis and have QSFP DD interfaces available. So it's all dependent on kind of what you have today, but most folks have something that will support some type of converged network.
Well, speaking of Josh nailing it, and let's get personal here for a moment. Do you feel like he's starting to get into your business here? Are you getting layer 3 guys thinking that they should be taking over all the optic side of things because of these kind of changes? You guys have been dealing with this together for years, but
No.
but I bring that up in just because it's a customer reality too, right? What is happening on the customer side, Tyler, that's important to understand in terms of careers and knowledge and where should we be studying and things like that?
Josh and I have been in this long enough where we understand that this is the type of role that you're in, be if I'm working for an operator or I'm working for somebody like WWT, where you're constantly learning, you're constantly evolving because the technology is evolving and you're always learning regardless. So yes, there will be some instances where customers are going to need to learn something new. There's always a new way of doing it. It's pretty ignorant of us to say that, this technology's worked for 20 years and it's going to be around for another 20, right? Everything goes end of life, everything goes end of sale, and eventually you're going to have to grasp onto a new technology. That said, there are management solutions built around this to kind of cater almost towards the old dinosaurs like me, where I'm used to looking at a GUI system, a graphical user interface with pretty lights that turn on when something goes bad. So there's plenty of systems that are out there that are capable of making that transition easier for not only the operators, but like their NOC technicians and people like that too.
In terms of vendor interoperability, who are the major vendors in this? And as I think I understand it, these systems are open in terms of your ability to share light in the C-band from one vendor to another and kind of set it so that these things can communicate without having to do too many huge forklift changes. Am I saying that halfway right? If anyone can pick that up for me.
Yeah, you're saying it right. So at OFC last year, they actually demonstrated multi-vendor coherent pluggable 400 gig optics working together. And that was, the list is endless of the pluggable optic vendors out there that are supported. The ones we traditionally work with, Cisco, Nokia, Juniper, Infinera, Ciena. Josh, am I missing anyone?
Those are the main ones that we work with.
Right.
But like you said, there are a lot.
Yeah.
I see there's a lot of cheap competition. Are there any warnings about optics made from unknown, foreign vendors or something that you should be aware of that's going to bite you somewhere else that you may not realize, even if the cost?
That is a question we get very often, and the standard response is typically you do it at your own risk. I've seen it work in plenty of instances, and I've also seen it not work. So you have to kind of assess that risk, and not to say that WWT wouldn't be there to help either. We do a lot of work with folks throughout our ATC to test pluggable optics and to have some type of strategy and some plan. So if you're planning on using vendor A with vendor Z, we can work with our customers to help make that type of testing and transition happen.
What's the adoption like, and what do you think holds back adoption? Is it knowledge? Is it awareness? Is it something deeper?
I would say knowledge definitely plays a role because while this is going on, like I said, about a half a decade now, it's very possible to have a situation, and we see this all the time, where an organization has just been chugging along, very happy with their routed layer environment and their routing engineers, very happy with their DWDM instantiation that they have and the engineers that run that. A lot of times, especially if those organizations are working somewhat in silos, this kind of becomes something that might just like fall by the wayside. That being said, because it's on the front page of every vendor's, carrier networking or core networking type of strategy, we're kind of getting to the point now where it's harder and harder to miss as time goes by. So it's a conversation that's almost Always relevant, like I said, especially if you're coming on a refresh, if you're coming on a redesign, if you have net new requirements that are going to force you to make some changes in your network in this way. This is probably going to be stuff that is at least going to be thrown out on the table for discussion, even if you don't move towards, some sort of converged architecture. In terms of the implementation and what it's like, I wanted to touch on earlier when you asked Tyler, hey, do you feel like the routing guys are kind of coming into your domain? And to a certain extent, there's probably an aspect of that as well. But there's the other side of the coin as well. So I can talk a little bit about from a routing perspective. Now we are configuring these pluggables on the router. So in the router's software, whatever that is for the different routing vendors, there are different settings and things that you need to get familiar with. And the main thing that has changed for me, and I think this changes for, routing guys, routing engineers who are out in the field starting to implement this technology, you kind of think of the world in this like ethereal way. It's hard to explain, but it's like you have these protocols have algorithms. They're not really analogous to anything in the real world. It's very just stuff like just the basic way that IP routing tables work and forwarding happens. It's very anomalous, and you have to learn it from the ground up to really get really, really good at it. When you start to learn how these optical systems work, and especially configuring some of these pluggables, it becomes apparent very quick that this is very real concrete technology. Meaning you look at your loss, you look at your spans, there are like calculations and things you can do to really crunch numbers. I've developed a huge appreciation for that. I almost like
Yeah.
that because again, it's not, up in your head philosophical type of stuff. It's real. It's at the end of the day, it's light. And light just has its physical properties. And smart
Yeah.
guys like Tyler, they know how to bend and twist the light and do all the things with it that will make these things work. And it usually is like, okay, we've engineered it, it's gonna work, or nope, the numbers don't match up. We need to keep hitting it, we need to fix it. Very different from the routing perspective where you're just kind of like trying to make the routing protocol function a certain way, or
It's gradations as opposed to
yeah,
binary
exactly.
changes.
So
Yeah.
there's a little bit of like a philosophy adaptation that occurs as you go through with it, but it's definitely a two-way street. You're definitely going
Yeah.
to have, because those networks are converging, you're going to really have to have both sides, the engineers or people with the backgrounds on both sides are going to have to get more familiar with doing it in this new way.
It sounds like there still needs to be a reason you're going through a refresh. You're increasing bandwidth between sites. Maybe data center interconnect, I would assume. Does design change, or does this open up new potential for efficient routing topologies?
When you're looking at a refresh of a network, be it your equipment's old and it needs to be refreshed,
Yeah.
or you're adding bandwidth to the network, or you're adding sites and you spin up a conversation with somebody like us, and we start to look at the entirety of the network. This is a great time to analyze how services have been delivered in the past, and maybe it was done a certain way to tailor fit a certain technology. Ring architectures are pretty common in our space, and whenever Josh and I have the opportunity to talk with a customer about a major network refresh, that conversation always comes up to say, hey, are these the paths we want? We see a lot of your traffic goes from here to there. How far are those geographically? Is there a fiber path between the two? Would it make sense to have a direct fiber run to make this thing more meshy? Because the more possibilities we have for a wavelength or a service to travel, the better survivability it's going to have, especially when you start talking about incorporating MPLS and routing technologies, because they can reconverge really quickly. And that's really the key to any network refresh, is to say, hey, is this what we want to see going forward? Is there a better way to do it? And we're there to help them with all that stuff. So
Let's talk a little bit about WWT's offerings in terms of helping people through making decisions in this area, and at the very least, educating themselves. Who would like to talk a little bit about what you guys do? Because I'm actually quite impressed with new stuff you've added over the years too.
Yeah, well, first and
Josh.
foremost, our team, so the core networking team that Tyler and I are a part of, we always have ongoing, workshops and briefings that are around this technology. So the first thing is, if you feel like you kind of need to get your foot in the door, maybe you've heard about this stuff, but you're not aware of all of the types of things that are out there. We can always hop on a quick call. Sometimes these are just an hour in length where we just kind of, put stuff out there. We want it to be a two-way conversation where we're not just kind of dumping, hey, here's everything that's out there now. Because like I said, the last 2 years, we've really seen a lot of new technologies get wrapped under this converged umbrella. but instead we want it to be a conversation about, well, what might be right for you based on what you're doing today, what you want to do in the future. So those are the first things is, just conversations and workshops, being able to whiteboard, being able to put ideas together and get that ideation. The second thing, we have a very robust environment that we call the multi-layer, multi-vendor lab, or MLMV for short. So this lab was spearheaded by a couple of our teammates, John Chiarini and Mike DiVincenzo, to really showcase there's a lot of different ways that this gets consumed. This is not cookie cutter anymore. It probably wasn't ever cookie cutter, but certainly today there's a lot of ways you can implement this, and there's a lot of different things it can do. So from the perspective of needing to have multi-layers of technology, so not just routers and then some coherent equipment and then maybe line systems, but all kinds of different things that the DWDM network can do underneath, as well as all kinds of different representations of routing networks. We want to be able to showcase different pieces and bolt on different things when needed. There's also the multi-vendor aspect where you really, I would say it's probably going to be uncommon at this point that organizations are going to implement a full single vendor solution for end-to-end converged technology of everything, every layer. The multi-vendor piece has just really become important because certain vendors are better at certain things or do different things in different ways that mesh well with organizations, or maybe they don't mesh well. So that whole multi-vendor piece is equally important. So basically we have a lab which we are using almost all the time now. It's up to full speed, and we're leveraging it all the time for different types of POCs, demos, and putting together storylines so that we can really start to showcase this for customers and get them used to the idea, seeing it in real time. We have, just as an example of how cool some of this stuff is, we have the gigantic fiber spools in the ATC so that we can simulate tens of kilometers of distance shot. All kinds of different things like that to try to make it
cool.
as real world and as applicable as possible.
So you have that distance running in a circle on the spool because it is the physical distance, even if it's all lumped together. Yeah, that's very cool. Is the multi-vendor thing a specific choice, or is it a function of how you kind of evolve into it, or are people buying fresh and saying I want multiple vendors because it lessens my failure domain or something? You're smiling, Tyler.
We haven't mentioned it yet, but cost is a giant driver for anybody making a decision. Obviously, they want something that's going to work for them, that's going to be stable, that's going to be dependable. But cost is a giant driver. So that's probably one of the larger reasons why somebody would choose one vendor versus another. Another one would be, in some organizations, they have to. They won't have their layer 3 network be the same as their layer 1 or vice versa.
Yeah.
So there's requirements for certain organizations, and some folks just are cost driven. Those are the two major drivers that I see.
Yeah, a lot of it is, to your point, Rob, it is historical. Organizations, they are made up of people at the end of the day, and the people have all of their backgrounds, and maybe they got burned by one vendor, or maybe they've just always loved one vendor their whole career.
Yeah.
So you come into that, again, because it's multi-layer and you're usually working with multiple entities within an organization, you're almost always just even starting out from that multi-vendor approach. But what we find is once we actually start discussing what the different vendors offer and what they have, you'll just find that there are better fits. And like Tyler said, cost is always, you can't always do everything you want to do. You have to make some hardline decisions, and cost is certainly a factor. But you usually find that operationally, vendors kind of fall into place based on what they do well. A big part of that is network management, a big part. Because
How so? Explain that further.
So because we're talking about multi-layer, you would have optical engineers who manage the optical network. You would have routing engineers who manage the routers and the routed network. Well, how are you going to manage this when it's converged, and what does that look like? Every one of the major vendors that we talked about earlier, they have kind of a different way for doing this, although the main idea is the same, right? We want to simplify. We want to give you more power, put the power in your hands in the form of a GUI, preferably something you access like through a web interface. So they're all doing that, but they do it in different enough ways that you'll find once you really dig into how an organization operates, what their operational structure is like, what their skill sets are, their backgrounds and everything, and basically what they're trying to do with their network, you'll find that network management often becomes a key driver of which vendor's direction they kind of head in.
We've got more flexibility now to make the choices you need to make, whether those are cost-based, legacy-based, preference. whichever there's a level of interoperability and a drive towards these smaller form factors that are playing well within standards, and vendors have agreed and invested in the same direction, so that you do have more choices as the consumer, so to speak.
We've talked a lot about architecture, design, hardware, equipment, but when push comes to shove, when rubber meets the road, we have to get this thing implemented somehow. And a lot of folks, it's new technology to them, or maybe they just don't have the staffing to be able to take on a sizable project. WWT can help with all of this stuff. We have plenty of resources to be able to help streamline that process if that's what that customer needs. We have plenty of folks to go out to the sites to be able to do the deployments, the integrations, the installations, the lifecycle support. All of that stuff is a really big deal. And even just coming up with a migration strategy, if that's what the opportunity calls for. So there's an awful lot of, I guess everybody puts that towards the back of the bus. And then eventually it'll come up, because usually everybody's talking about the architecture, the design, which piece of hardware we're going to use for this and that and the other thing. But eventually, the implementation does have to happen, and we're there to help for all that.
You reminded me of an old IBM consulting commercial, I think it was, where they would, they say some wonderful things back and forth, and everybody's excited, and then at the end they go, oh, we have to implement this, or something to that effect, which has always been funny to me, because that's a good distinction to make, is that there is a reality. You guys assist with that reality. In fact, I was kind of thinking through, one of the drawbacks to this form factor of this show that you're on today for the research series is that we are a broadcast format. There's not really Q&A that's going to guide the changes. Someone watching this isn't going to be able to say, well, I have this in this place and this in this place. What do you recommend? They're going to kind of put it together. But that is where you guys step in organizationally, and that is the logical next step, which is to say, hey, guys, can I come in and whiteboard for you, or at least just discuss what our layout is, and you tell me, is it something I should be investing in, or can I wait another year or two or more? Maybe there's something on the horizon I'm not even aware of. I do love the fact that you guys span so many different architectures, industries, verticals, and all that knowledge then comes into providing advice. You pour that back into these lab resources, which are all available remotely. It's not something you have to travel in for, although a trip to Mecca, I think, is always kind of fun. I like to get to St. Louis once in a while. But what I love is that you guys have made it so that you don't have to. Josh, thank you so much. I appreciate your time.
Yeah, thank you very much, Rob.
And Tyler, always a pleasure.
Yes, thank you, Rob.
Well, we started this conversation by challenging an outdated assumption that optical transport and core routing must remain separate disciplines. What we've learned today is that not only has convergence arrived, but it's matured to the point where it needs to be part of every network design conversation. Josh Hogan showed us how this technology has evolved beyond service providers to become a viable option for any organization with their own fiber, from enterprise campuses to hospital systems. And Tyler Tappy demonstrated how advances in pluggable technology are eliminating entire systems of hardware, dramatically reducing power consumption and complexity. If network scalability, efficiency, and cost reduction are priorities for your organization, the time to explore this technology is now. But as we learned today, there's no one-size-fits-all approach. And that's where WWT's multi-layer, multi-vendor, that's the MLMV lab, comes in. This unique environment lets you test real-world deployments before making critical investments. Using actual fiber spools to simulate distance, you can validate solutions across multiple vendors and see exactly how they'll perform in your network. WWT's latest research paper, Networking Priorities for 2025, dives deeper into this transformation and outlines key considerations for organizations making the transition. I encourage you to download it and then schedule time with WWT to explore this MLMV lab and put these innovations to the test. You know what's interesting? We just spent the last 30 minutes or so discussing a fundamental transformation in how networks are built, and we didn't mention AI once. I mean, I may have mentioned it, but that didn't count. While AI grabs the headlines, opportunities like this one quietly reshape our infrastructure. And as our need to move massive amounts of data continues to grow, these advances in network convergence aren't just nice to have, they're becoming essential. Because sometimes the most important innovations are the ones that don't make the trending topics list. My name is Rob Boyd. Thanks so much for joining us on WWT Presents Research.
This episode is brought to you by Netscout, guardians of the connected world that assures digital business services against disruptions in availability, performance, and security. See across any network, any data center, any cloud, 5G, and more. That's the power of visibility without borders.